Hey guys, welcome to my video on solving rational equations. So we're just going to briefly review how to solve these equations where we have algebraic expressions in our denominators. Okay, so now you hate fractions with numbers. I'm sure you'll hate fractions even more with variables. So when we are solving these rational equations, the goal is going to be eliminate the denominator as quickly as possible. So how do I do that? Well, in order to eliminate the denominator, okay, what we're going to need to do is find what the least common denominator is, right, the LCD of each term within my equation. So I look at the denominators of this fraction, and this fraction to see what factors I need to cancel out. So obviously this is over 1. So whenever we have a denominator of 1, we don't have to worry about that one. So we look at the other two. What is an algebraic expression that I can use to multiply by that will cancel out all the denominators in my question? And in this case, it's the denominator x minus 8. Okay, so what I'm going to do is I'm going to multiply every single term in this equation by my least common denominator. So I multiply this by x minus 8. I multiply this 1 by x minus 8. And I multiply this fraction by x minus 8. Now, anytime we have something the same in my numerator and my denominator, I can cancel it. So we look on this side. This in the numerator over this in my numerator cancels out. I look at this first fraction. This in my numerator and this in my denominator cancel out. So all that's left for that first term is just a 1. Now nothing canceled out in my second term, so I carry it over a minus 1 times the entire parentheses. And the 7 is the only thing left on this side. All right, so all that's left to do is to distribute and solve for x. So that's plus 8 is equal to 7. Minus x plus 9 equals to 7. Minus 9 on both sides. We get x is equal to 2. Now, we can't be so quick to move on to the next question because we know that there's a possibility for extraneous solutions. All right, so now how do we get an extraneous solution with rational equations? Well, any value, right, that will make my denominator of any of the fractions equal to 0 will be rejected as an extraneous solution because this, having a denominator of 0, is what we call undefined. Okay, so anything that makes my fraction undefined is going to be rejected. So we look at our denominators. If I substitute a 2 in here, I get a number that's not 0. That can stay. If I substitute 2 here, it's not going to give me a 0, so that can stay. So 2 is a solution to this equation. There are no extraneous solutions, but we always check all of our denominators. So let's try another one. First step, right, is to find the LCD. What is the LCD of all denominators? So we look at our denominators. We have a denominator of 1, a denominator of x minus 4, and another denominator of x minus 4. What is common to all of those that will be able to cancel this out? In this case, it's x minus 4. Okay, so once I find that LCD, I multiply every term by the LCD. And this should cancel out my denominators. If I have a denominator left with a variable, I have made a mistake. All right, so I multiply by x minus 4, and x minus 4. All right, in this fraction, that will cancel. In this fraction, that will cancel. And on the other side of the equal sign, nothing cancels, so I bring it along. So 1 times x minus 4. What's left over on this fraction? Well, that's an x plus 2. What's left over on this fraction? Well, that's a 7x minus 42. All that's left is for me to continue solving. So I combine my like terms. X plus 7x is 8x minus 2 plus 40. Plus 2 minus 42 is minus 40. We move everything. We don't move everything over. We isolate our x value by moving things to the appropriate side. So that will cancel and that will cancel. And I end up with negative 7x is equal to negative 36. And I divide by a negative 7. So these negatives cancel and I get 36 over 7. So now the only thing that will stop this from being a solution is if my denominators will become 0 if I plug this number in. Now 36 divided by 7 just gives me a decimal. So if I take that value, subtract 4, it does not make it 0. So we're in good shape. That is a solution. All right. So now in this particular example, we actually have a denominator that is factorable. Now, my recommendation will be always factor those denominators first because it could give you a better idea of what factors need to be in my LCD. All right, so this denominator is x, GCF, with x minus 2 left over. And this denominator is x with x minus 2 left over. So they happen to be the same thing. All right, so we're just going to see that this is exactly our LCD, all right? So even though it's in factored form, I can still multiply each fraction by this. So x minus 2, this inside x minus 2, and on here x minus 2. Anything that is in common, numerator to denominator, can get canceled out. So minus 2, x, what am I left over with? An x plus 5. Well, in the second one, right, I have a minus x minus 2 because nothing canceled out. And over here we have x and x minus 2 canceled out. So these denominators are gone. All that's left is a 1. All right, so now we have to simplify. So I'm going to distribute my x. So I get x plus 5 minus x squared plus 2x. Not equal to 0, equal to 1. And I see that I have a quadratic. So because it's a quadratic, what I'm going to do is I'm going to set it equal to 0 and put it in standard form. So I combine my like terms and I get 3x plus 5 is equal to 1. I bring this 1 over and I get minus x squared minus 3x plus 4 is equal to 0. Now because my leading coefficient is not equal to 1, it's equal to a negative 1. I'm going to divide every term by negative 1, okay? And I get a positive x squared minus 3x minus 4. And this is factorable to get x minus 4, x plus 1, leaving me with the solutions. X is equal to a positive 4, and x is equal to a negative 1. So now we have to check, do either of these values make my denominator, which in this case it'll be easier to check our factored form, equal to 0. Well, 4 doesn't make this factor equal to 0 or this factor equal to 0, so that's good. And negative 1 doesn't make either of them equal to 0, so that's good. So there are no extraneous solutions here. All right, so let's try this very last example. All right, so here we have 3 totally different denominators, but what we should notice is that one of these denominators is factorable, which may be helpful in helping us find the LCD. So this denominator on this side, I'm going to factor as x minus 4, x minus 2. Okay, we should notice that each one of those factors is in the other fractions. So when I look for my LCD, right, I'm looking for factors that will cancel out every denominator. So I need at least, for this first fraction, right, an x minus 2. I need at least an x minus 4 for the second fraction. And because on the last fraction, I have both of those two factors already, I don't need to add anything to my LCD. So x minus 2, x minus 4 is the LCD. So I multiply each term by this expression. X minus 2, x minus 4, x minus 2, x minus 4. So what cancels? Well, in this fraction, x minus 2 and x minus 4 cancel, so the whole denominator goes. In this fraction, the x minus 4's cancel, and in this fraction, the x minus 2's cancel. So what is left over? Well, we have x times x minus 4 for the first fraction. We have a 1 times x minus 2 for the second fraction, and just the 2 left over. So all that's left for us to do is to distribute and solve. So we get x squared minus 4 plus x minus 2. I move this over and combine our like terms. So I get x squared plus x, and there's minus 4 minus 2 is minus... Oh, I made a mistake here. Sorry about that. When I distributed here, I forgot to include the x with the 4. So now we can combine our like terms, and I still can move this over. So x squared minus 3x minus 4 is equal to 0. Notice that's the exact same question we did in the last problem. So we already know the factors are minus 4 and plus 1. And those give me the results, x equal to 4 and x equal to negative 1. So now we have to check back to our original denominators if it makes anything equal to 0. Well, we have a problem. X equals 4, when I plug it into this denominator, gives me a 0. So we must reject this as an extraneous solution. It only needs to make one of the denominators equal to 0 to make it a problem. But if we actually look at this side, we see that this would also be a 0 if x was equal to 4. So that's no good. X equal to negative 1 does not cause any problems, so it is our one and only solution. All right?